So let's solve this question. We have been asked to consider the following list of processes that need to be scheduled on a single CPU using SRTF scheduling algorithm. So what is SRTF? SRTF stands for shortest remaining time first. This scheduling algorithm works on the execution time, and also it is a preemptive scheduling algorithm. Sometimes it is also known as the preemptive version of the shortest job first algorithm. So what we have to do is we have to simplify the average turnaround time, and this has been asked not so far back, only in GATE 2014. So in order to solve such questions related to CPU scheduling algorithms, we need to construct the NAT chart. Okay, so let's get this done. Now remember, when we have to construct the NAT chart, the time always starts from 0. Now 0 time doesn't mean that the process is arriving at time 0 as such. Time 0 here refers to relative time. That means if process A has an arrival time of 0, it means that it arrived at the beginning, right at first, compared to the other processes. So if process B has an arrival time of 3, it means that it is relative time 3. Here also it is relative time 5, and so on. So we can see that process A arrived at time 0. Now at time 0, no other process is available, as we can see. So we have no other choice but to schedule process A. So process A will get scheduled for how many units of time? For 3 units of time. So process A gets scheduled for 3 units of time. And out of 6 units of burst time, we are now left with 3 units for process A. What is ET? ET is the execution time or burst time. Now see, process A has executed for 3 units and it has 3 more units left. Now at time 3, process B is also available. So now we have 2 processes, process A and process B. These 2 will now be competing against each other. How? The CPU scheduler will look at the remaining execution time. The remaining execution time of process B happens to be 2, whereas that of process A happens to be 3. Since 2 is lesser than 3, we will schedule process B. So the CPU will be preempted from process A and given to process B. So it will run for 2 units and it will give up the CPU. So that's the end of process B. Now see, at time unit 5, we have with us 2 processes available. We have process A and process C. Now, out of these 2 processes, which process has the lower execution time? Process A has a lower execution time of 3. So it will get scheduled first. So process A gets rescheduled rather for how many units? Let's say if it gets scheduled even for 2 units, because at time 7, we have another process with us, that is process D. Now at this point in time, at time 7, we have process A, process C and process D. But still it doesn't make any difference because process A continues its execution and its burst time drops. As its burst time drops, its priority will increase because shortest remaining time first scheduling algorithm works on burst time. Lower the burst time of a process, greater is its chances of getting scheduled. So process A will continue having the CPU. It will execute for 1 more unit and give up the CPU. Now at time 8, see, at time 8 we have 2 processes with us, process C and process D. Now out of these 2 processes, which one should be scheduled? If you have a good look at it, you will find that process C has a lower execution time. So it will run. So let me see. What is the next time at which a new process would arrive? At time 10. So let me run process C for 2 units and then see what happens. So process C gets scheduled for 2 units and we have time 10 here. So process C is now left with 2 more units of burst time. Now at this point in time, at time 10, we have with us process C, process D and process E. Now out of these 3 processes, again, since C has been executing with the CPU, its burst time has been decreasing, and as its burst time decreases, like I mentioned, its priority goes up, and process C will continue having the CPU. So it will have the CPU for 2 more units. It will have the CPU for 2 more units, and then it will finally give it up for any other process to get hold of it. Now see, process D and process E has the lower burst time, so it will get scheduled and it will run for the entire duration, right? Because here process D has a burst time of 6, process E has a burst time of 3. Now out of these two, 3 is lesser. Now if process E gets hold of the CPU and starts executing, its burst time will continue to decrease. As a result, it will continue having the CPU till its execution time is over. And we have 3 units for E. Finally, process D will get hold of the CPU for its execution time, which happens to be 6 units. So process D is over, and this is our final NAT chart. This is the final NAT chart that we have got for these 5 processes. Now, our job is not over, mind you. We have to find the average turnaround time. Now, in order to find the average turnaround time, we need to find a few other parameters first. One of those parameters is CT. CT stands for completion time. Remember, for preemptive scheduling algorithms, if you have to find the completion time, you must scan the NAT chart from right to left. For non-preemptive scheduling algorithms, you can go from right to left or from left to right. It won't make any difference. But for preemptive scheduling algorithms, you must go from right to left. So let's see. So in order to find the completion time, I'll traverse the NAT chart from right to left. Now while traversing, I find process D. Process D has a time slot of 6 units, and this time slot gets over at time 21. So the completion time of process D is 21. Next, while scanning, I encounter process E for the first time, and I find that the time slot of process E gets over at 15th unit of time. So its completion time is 15. Moving on, I find a time slot for process C, and this is the first time I've encountered process C, and I find this time slot to get over at 12. So its completion time is 12. Now moving on, again I find process C. Should I process this? No. Whenever you encounter a time slot for a process for the first time, you take that into consideration. From then onwards, if you encounter any other time slot for that very process, you can ignore it. Since we have already encountered a time slot for C and we have found its completion time, we will ignore any time slots that occur after it. So this time slot will be ignored. Now we encounter a time slot for A for the first time, and that time slot gets over at time 8. So the completion time of process A is 8. Moving on, we find a time slot for A again, which will be ignored, and we find a time slot for B for the first time, and that time slot gets over at 5. So the completion time is 5. I hope this is clear to everyone. Now after finding the completion time, we are in a position to find the TAT, that is turnaround time. What is turnaround time? Turnaround time, mind you, is the total time spent by a process in the system. That means the time at which it entered till the time it leaves the system. So turnaround time is the total execution time, mind you, total execution time, not only the time it spends with the CPU or not only the time that it spends doing input output. It is the total time that it spends in the system, right from its point of arrival. So you can see, or you can probably understand now, that the turnaround time for process A will be the completion time minus arrival time. So the completion time for A is 8, arrival time is 0, giving us a turnaround time of 8. For process B, we have a completion time of B to be 5 units and arrival time to be 3 units. So the difference 5 minus 3 gives us 2. Similarly, 12 minus 5 will give us 7. Remember, turnaround time is completion time minus arrival time. If you remembered the logic, I don't think you need to remember the formula. But then again, it's a personal preference. So completion time minus arrival time for process D will give me a value of 14. I hope I'm not making any mistakes when it comes to calculations. And for process E, we have completion time of 15 and arrival time of 10, giving a difference of 5. So we were asked to find the average turnaround time. So in order to find the average turnaround time, what I can do is I can simply find the mean of the turnaround time of the processes. So see, I have the turnaround times with me, 8 plus 2 plus 7 plus 14 plus 5. The sum divided by the number of processes. In this case, it happens to be 5. So if you calculate this, you'll get 8 plus 2, 10, 17, 31, 36. Let's do it again. 5 plus 14, 19, 26, 28, 36. Yes. So it's 36 divided by 5. So on dividing 36 by 5, I get 5 goes in 36 7 times, leaves a remainder of 1, so I get 2. So the answer is 7.2 units. Right? I hope this has been understood by all my viewers. If you have any doubts, you can leave a comment in the section given below. Thank you.